A gramophone is driven by a Pickering Governor. The mass of each disc attached to the center of the leaf spring is 20 gram, right? So mass of each disc is 20 gram. Each weight which is attached to the leaf spring is 20 gram. Each spring is 5 millimeter wide and 0.125 millimeter thick. Right? The effective length of each spring is 40 millimeter. The distance from the spindle axis to the center of gravity of the mass when the governor is at rest is 10 millimeter. Find the speed of the turntable when the sleeve has risen 0.8 millimeter and the ratio of the governor speed to turntable speed is 10.5. Take E as 210 kilonewton per millimeter square. Right? So this to extract the given data first, right? Leaf spring, mass on the leaf spring, right? Mass of each disc attached to the leaf spring is 20 grams. So M is equal to 20 gram. That is equal to 0.02 kilogram. Okay. Each spring is 5 millimeter width, right? So wide. So B is 5 millimeter. Why we need B? We have to apply it here, right? So B is 5 millimeter. And we also need the thickness, which is given. Thickness is 0.125 millimeter. Thickness is 0.125 millimeter. Effective length of the spring is 40 millimeters. So L is 40. The distance from spindle axis to the center of gravity of the mass is at rest is 10 millimeter. Right. So here A is 10 millimeter, which is A. This is A. Right. So when it is at rest, is 10 millimeter. Here it is A plus delta, that is A plus deflection. So here the question is, you see here is at rest is 10 millimeter. So A is 10 millimeter, that is 0.01 meter. Right, this is the given data, and also the modulus is given. Right, modulus is 210 kilonewton per millimeter squared. Okay. Now we'll calculate. We have all the formulas here. Right. We have the empirical formula, lambda is equal to 2.4 delta squared upon L. We have moment of inertia formula, B T cube by 12, and we have the formula for delta, that is W into I cube by W into L cube by 192 EI. Right. We'll just simply apply. We'll take the moment of inertia format first. Right. So I, that is equal to BT cube by 12. B, that is given 5 millimeter, T cube, that is 0.125 millimeter whole cube upon 12. So when you solve it, you will have moment of inertia is equal to 0.8 into 10 to the power minus 3 millimeter to the power 4. Okay. Since the effective length of each spring is 40 millimeter and lift of sleeve lambda is 0.8 millimeter, therefore length of the spring between the fixed ends is, so we know this is the effective length of the spring. Now there's a lift that is 0.8 millimeter. So we just need only this part of the length, that is equal to total length 40, that is effective length 40 minus lift, that is given, it is 8 millimeter, right? That is 8 millimeter. So which is equal to 39.2 millimeter. All right, 39.2 millimeter. Why effective length is 40, that is given. Lift, that is also given 0.8 millimeter. So 40 minus 0.8, 39.2. So L is given 39.2, right? So from this, we know that center deflection lambda, we can find it. So based on the empirical formula, 0.8, that is the lambda, right? Lambda is equal to 0.8, that is the lift, right? Which is equal to 2.4 delta squared upon L, right? So 2.4 into delta squared upon 39.2, right? L is 39.2, we have already found. So which is equal to 0.06 delta squared, right? 0.06 delta squared. And delta squared is equal to 0.8 upon 0.8 upon 0.06, right? 0.06, which will give you 13.3. Okay. So if delta squared is equal to 13.3, then delta is equal to 3.65. Okay. Now we'll see. We have to find also. What's the question? Find the speed of the turntable when the sleeve has risen this much, and the ratio of the governor speed to the turntable speed is 10.5. So we need to find that also. Right. So now we'll consider N as the speed of the governor and N1 as the speed of the turntable. And we need this ratio to be 10.5. N upon N1 should be 10.5. Right? And we know that delta is equal to M omega squared. Right? So this formula we are going to apply. Delta is equal to M omega squared into A plus delta into L cube upon 192 EI. Right? So M omega squared into A plus delta into L cube upon 192 EI. So when I replace it, 3.65, delta is equal to 3.65, we have already found, equal to M, that is given 20 gram, that is 0.02 into omega squared, which we have to find again within bracket A, that is at rest, the distance between weight and the shaft, that is 10 plus delta, which is given 3.65 into L cube that we have already found here 39.2, right? L, that is 39.2. So 39.2 cube upon 192 into E, that is Young's modulus, which is given 210, right? So that's given in the question. E is equal to 210 kilonewton per millimeter squared, right? So that is 210 into 10 to the power 3, since it is kilonewton. Then I, which we have already found, 0.8 into 10 to the power minus 3, right? I we have found 0.8 into 10 to the power minus 3, right? So 0.8 into 10 to the power minus 3. So when you solve it, I will have 3.65 is equal to 16,445 omega squared upon 32,256, which is equal to 0.51 omega squared, right? So if 3.65 is equal to 0.51 omega squared is equal to 3.65 by 0.51, which is equal to 7.156, right? If omega squared is 7.156, we know omega is equal to 2.657 radian per second, right? So if we find the omega, we can calculate the n, which is in RPM. So how will we calculate it? N is equal to omega into 60 by 2 pi, right? So omega it's already found 2.675 into 60 divided by 2 pi, which is equal to 25.5 RPM, right? So n, that is the speed of the governor. We need to find the ratio of the governor speed to the turntable speed, right? So ratio is given as 10.5. So if n upon n1 is equal to 10.5, we'll substitute this value there, right? So n1 is equal to n, which we have now found to be 25.5 upon 10.5, right? So when you solve it, you will have 25.5 by 10.5, which is equal to 2.43, right? So the question is, find the speed of the turntable and also the ratio of the governor speed to the turntable speed, right? So this is the final answer for this ratio, right?